The next chapter that we are going to see is evaporation and its measurement. So first question, the Thiessen polygon is a polygon obtained by joining adjoining rain gauge stations. B. A representative area used for weighing the observed station precipitation. C. An area used in the construction of depth area curves. D. The descriptive term for the shape of a hydrograph. So we have earlier studied that the Thiessen polygon is used in the Thiessen mean method in order to calculate the area which each of this polygon or each of the rain gauge station represents. So we can say that it is nothing but the representative area used for weighing the observed station precipitation. That is, we have earlier studied that P average is calculated in Thiessen polygon method as P1A1 plus P2A2 plus etc. up to Pn the whole divided by the total area, where P1, P2 etc. up to Pn are the rainfall data of areas A1, A2, An. And this Thiessen polygon method of calculating the average precipitation is superior when compared to that of the arithmetic average method, and more accurate method than this Thiessen polygon method is the isohetal method. So here it's nothing but the option B. The second question, a lysimeter is used to measure infiltration, evaporation, evapotranspiration, radiation. The answer is evapotranspiration. Now measurement of evapotranspiration is done in two ways, either by using a lysimeter or by using a field plot. Lysimeter studies are time consuming and expensive. That is option C is the answer. Now the third question, a lysimeter and tensometer are used to measure respectively one of the following groups of quantities. We already know lysimeter is used to measure evapotranspiration. So this is the option. So tensometer is used in measuring the capillary potential. So option B is the answer. Now the next question, the Bowen ratio is defined as ratio of heat and vapor diffusivities, then proportionality constant between vapor heat flux and sensible heat flux, then ratio of actual evapotranspiration and potential evapotranspiration, then proportionality constant between heat energy used up in evaporation and the bulk radiation from a water body. So the Bowen ratio, it is the ratio of heat and vapor diffusivities, and there is a formula for this which is equal to HA, which is the sensible heat transfer from water surface to air, by rho LEL, and that can be also written by this equation, and where PA is the atmospheric pressure in mm of mercury, EW is the saturated vapor pressure in mm of mercury, EA is the actual vapor pressure in mm of millimeters of mercury, then TW is the temperature of water surface in degrees Celsius, and TA is the temperature in air, and this is how you calculate the Bowen's ratio. So the option is option A. Next question, isoplates are lines on a map through points having equal depth of rainfall, infiltration, evapotranspiration and total runoff. So here the mean annual PET or the potential evapotranspiration in centimeters over various parts of the country is shown in the form of isoplates, and these isoplates are the lines on the map which have equal depth of evapotranspiration. So the option is option C. The next question, the average surface area of a reservoir in the month of June is 20 km square. In the same month, the average rate of inflow is 10 meter cube per second and outflow rate is 15 meter cube per second. The monthly rainfall is 10 centimeter and monthly seepage loss is given as 1.8 centimeter, and the storage change is 16 million meter cube. Now the evaporation in centimeter in that month. So here again it's a water budget equation problem. Here the area of the catchment is given as 20 km square. Then the average rate of inflow is given as 10 meter cube per second, outflow is given as 15 meter cube per second. Then the rainfall P is 10 centimeter, the seepage losses is 1.8 centimeter, and the storage change is given as 16 million meter cube. So here we can see that all of them are having different units, so we have to convert all that into centimeter so that we get the evaporation in centimeter. Now first, let X centimeter be the evaporation taking place in the month of June. Now total inflow is given as 10 meter cube per second, so we have to convert it into centimeters. For that, 10 into, it is said that the inflow is given for, this inflow is 10 meter cube of water is flowing per second, but we are asked to find for a month. So multiplying by the 1 month means 30 days. So 10 meter cube per second, 10 meter cube per second into 30 days. Now converting, we have to get the answer in second, then only these two will cancel off. So 10 into 30 days into 24 hours into 60 into 60, we will get the answer or the numerator in meter cube. Now we have to divide the denominator, this unit is meter cube, and now we have to divide it by the catchment area, which is 20 kilometer square. So in order to convert it in meter square, 20 into 10 raised to 6 meter square. So that is what is done here, divided by 20 into 10 raised to 6. The whole answer that we get here is in, so this unit will be in meter square. So meter square and meter cube cancel, it will be in meter. Now we require the answer in centimeter. So we are multiplying by 100, and that plus the 10 centimeter here, 10 centimeter rainfall here, that is also an inflow or the water that is added into the catchment. So plus 10 centimeter, we will get it as 139.6 centimeter. Similarly, outflow is also given as 15 meter cube per second. So similarly converting it, 15 into 30 into 24 into 60 into 60 by the area 20 into 10 raised to 6. Now we will get the answer in meter. To convert it, multiply by 100 plus 1.8 is the seepage loss that is already given in centimeters. So we just need to add plus the evaporation loss, that all comes under the total outflow. We get the answer as 196.2 plus x. Now we know that here, as you can see from these values, we know that the outflow value is greater than the inflow value. Therefore, depression in storage takes place, or dip in storage. There will be, that is more, the total inflow or the amount of water coming in is 139.6, but the amount of water flowing out is 196.2 plus x. So more amount of water is flowing out, that means there will be a dip in the water storage. That is why there is a negative term given here, and the value for that storage change, here the unit is 16 million meter cube, that is 16 into 10 raised to 6 meter cube it is given. Now we have to divide it by the area, which is nothing but 20 kilometer square, and multiply by 100, so as to get this value, that is 80 centimeter. Now equating these two, the formula is inflow minus outflow is equal to the change in storage. So the total inflow is 139.6 minus the outflow is equal to negative 80, and we get the answer as 23.4. So the option is D. So that's all from this chapter. Thank you.